Okay, this is lesson number 5, hypothesis testing, one sample, the coreq material. So what I want to cover in this video is we get things in hypothesis testing called a test statistic. Now this will be a Z statistic, and it has this notation p hat, which we should know by now is the sample proportion. P is the population proportion. There's P again, same thing. Q in this case is just 1 minus P. And then of course N is just the sample size. So what we do in is sometimes we have to calculate these again, test statistic. Calculate these things by hand. So the purpose of or at least the focus of the co-requisite material for this lesson is to just run through how we calculate these by hand. Now, typically speaking, usually speaking, when we run what's called a test of hypothesis, we calculate the test statistic using StatCrunch. But again, all these problems have these little caveats to them and these different ways of approaching and different ways of looking at the problems, and sometimes we need just a straight, direct approach. So it turns out it's actually pretty easy. So let's say that p hat is 0.42, and let's say that p is 0.50, and let's say that n is equal to 500. And we need to calculate Z, which is the test statistic. Well, it turns out it's pretty easy again. First thing, just plug and chug. So the p hat is 0.42, so we put that where it belongs, the 0.50. Then we have over the square root of p, which is 0.50. 1 minus 0.50 is 0.50, probably should use something different. And a lot of 5s here, all right. So if we can put this in our calculator without doing something really goofy, then we get the correct answer. So I think it's going to help all of you if you think about the numerator being in parentheses, because all of that has to be done before we dive into this calculation. So let's just do it. All right. So let me get this where you can see it a little bit better. All right. So I would do all this in one step, not necessarily that you have to. So again, the reason to put that in parentheses, I see a lot of times students will forget the parentheses and just put it in like this, enter this into your calculator. Well, what happens is order of operations will kick in. It'll perform all these operations over here first and then subtract all that from 0.42. Well, long story short, you get the wrong answer. So, not cool. Always put, unless your goal is to get the problem wrong, if it is, do that. It'll work every time. Now, the next thing we do is we do the square root. Can't find that. And then I just need 0.5 times 0.5 divided by 500. And hit my right arrow to get out of that. Hit enter. And I can see I get negative 3.5, or whatever it tells you to round to in my stat lab. If it says round to 2 places, it would be 3.58. If it says 3 places, it would be 3.578. If it says round to 4 places, it would be negative 3.5777. Always look at the next digit, round accordingly. So 2 places, this would be negative 3.58. Now, something that can happen is sometimes your p hat all right, let's put in some kind of messy numbers. Sometimes your p hat can be as a fraction. And I can tell you that if you try to put 11 over 42 there and 11 over 42 there and then 1 minus 11 over 42, Well, no, I'm sorry. The 11 over 42 would just go there. It can get kind of messy. So I'm going to show you how in your calculator to keep that from getting so messy. Again, this 42 has absolutely nothing to do. This is the first problem. This is the second problem. It's a completely different problem. I don't know why I'm stuck on 42 today. But the 11 over 42, nothing to do with that up there. So what we would end up having here is we would end up having 11 over 42 minus 0.20 over the square root of 0.20 times 0.80 over the sample size of 856. Now again, why 0.80? Well, because this part right here, the Q, is 1 minus P. So in my head, I can just do 1 minus 0.2 and know that that is 0.80. Now, how do I put this in the calculator to get the right answer? So this is what I have found probably most effective. I put the 11 divided by 42 in and just let it ride, okay? Then I start the problem. Well, what I'll do is I'll come second function ANS. What this ANS key, and again, it's right here. You'll see it in blue on my calculator, telling me I have to hit the blue key first, then hit the ANS key. What it does is whatever the answer is from the previous problem, it'll kind of copy and paste that and put it right there. So I don't have to worry about typing the 11 over 42 and making sure I get the order of operations in parentheses in the right place. So minus 0.2 divided by the square root. And now I need 0.2 times 0.8 divided by 856. And double check, and I get 4.53. All right, so you have to probably agree with me. Not too bad, as long as I think it really helps to write it out first, so you can see it, and it's right there in in clear print before you put it into your calculator. At least I've found over the years of teaching that that extra step seems to pay huge dividends. Now, another type of test statistic that we have is called a t-statistic. And again, the purpose of this video is not to teach you what a t-statistic and a z-statistic, to teach you what those things are. I do that in the rest of the video. The co-requisite video is just to focus on kind of the mechanics, the underlying skills needed to be successful at this. So these turn out to be pretty easy if you'll appreciate that has to be in parentheses. So let's say that x bar is equal to 52. Let's say mu is equal to 70. Let's say S is equal to 11. And let's say N is equal to 400. So we want to calculate the test statistic. Again, first thing we want to do is write it out. So x bar is 52. Remember, that's the sample mean. Mu is 70. Goes in the next spot. Just to help us get it right, let's put that in parentheses. The S is the sample standard deviation. And 400 is the sample size. That also has to be in parentheses. The parentheses just help you, when you enter this into your calculator, to make sure that you get the order of operations correctly. So let's go 52 minus 70 divided by, again, let's go parentheses to be safe, 11 divided by the square root of 400. Need to go to the right to get out of that, put the parentheses, because I want that parentheses to contain or to end the entire expression of the 11 divided by square root of 400. All right, so hit enter, and I get negative 32.8 73. If rounding to two places. Now the Z statistic you'll find is, and again, these are a test statistic for a claim about a population mean. This is a Z statistic for a claim about a population mean. What we had on the other page was a Z statistic about a population proportion. Again, I teach all that to you in the videos, if you'll watch them. Some of you are reluctant to watch them, and it kind of takes me out of the game. I really feel like I don't have a lot of stake in your success because you're not allowing me to teach you anything. But for those of you that are watching, I can tell you're doing well in the class because the instruction's there if you just use it. All right, so these are pretty much the same thing. We have a sample mean. Let's say it's 32 in this case. We have a population mean. Let's say that it's 30. And sigma, let's say, is 15. And N is 88, whatever. All right, so to calculate, let's write it out again. So X bar 32, mu is 30. Put in parentheses because it helps us get their answer right. 15 over the square root of 88. Put it in parentheses because it helps us get the problem right. All right, so let's go for it. 32 minus 30 in parentheses, 15 divided by the square root of 88. Hit the right arrow to get out of the square root, so you put the parentheses where it needs to be, and you get 1.25. Now, I've made a big deal about the parentheses, and I just want to show why. So let's say we're like, Darby doesn't know anything. He didn't know anything about parentheses. Let's just do it the way that I want to do it. All right, so let's try that. So we have 32 minus 30 divided by 15 divided by the square root of 88. Kind of looks the same, right? In a way, it looks completely different to me because I have the experience with this stuff. But if you're just kind of learning, it kind of looks like the same. It kind of looks like, with the stretch of the imagination, what you have right here. Well, if you want to get the answer wrong, then do that, right? Don't use parentheses. You'll get it wrong every time. But if you want to get the answer right, then use the parentheses as I'm trying to teach you. Now, the next page, we get into something called chi-square. We don't study chi-square in this form, but I think it's kind of a good exercise to calculate a chi-square test statistic. So there's three parts to this. There's a sample size. So for this, let's say that the sample size is 800. The other thing we have is called the sample variance. So S squared is the sample variance, and let's say that it's 200. And the next thing we get into is called the population variance, and let's say it is 180. Well, to calculate the chi-square statistic, looks like a big X square, right? One statistic it's called chi-square. Well, actually, in lesson number 6, dive into the chi-square statistic. It's a way that we can express the relationship between categorical variables, but more about that later. All right, so let's plug and chug. N minus 1, S squared, sigma squared, 180. Now, this is a place when you have multiplication and division, you don't have to be as careful with parentheses, because again, in my please excuse my dear Aunt Sally, the my dear, the M and the D, the multiplication and the division, all happens in the same line. So this is pretty easy in that I just have to take the 799 times the 200 and just divide it by the 180. I don't necessarily have to have in parentheses. And I'll show you why in just a second. So here we get 887.78. Now, why don't I need parentheses here? Well, first of all, I don't have, in this, I don't have, pluses and minuses, right? So I'm not adding and subtracting, so I don't need to differentiate that. But if I take 799 times 200 divided by 180, this is the same as 799 times 200 over 180. So the way I enter in my calculator, if I go this times this divided by this, or this times this divided, it's the same thing. So your calculator understands that order of operations. Now, change this slightly to 799 plus 200. And again, don't do that. This is not what we're doing here. I'm just using this down here is it's just completely different. This is something different down here. So if I get this, I can't do that. This part up here, because it's addition, has to be done first before we can actually do the multiplication. That's where we get into the P part of please excuse my dear Aunt Sally, parentheses. All right, that's all I've got. So far we've had sneaky quizzes. Let's have another one. So sneaky quiz, this is for lesson number 5. Again, email to me. For an easy 25 points. All it has to be done is send in before the assignment in my stat lab for lesson number 5 is due. Once it's due, you can't turn it in, not even for half credit. Last time there were only 3 people that did this. But hey, you 3 people got an easy 25 points, which, boosts your grade. And I'm going to reward the people that I know are watching the videos because, again, you're giving me an opportunity to teach you something, which is kind of the way this whole crazy game is supposed to work. So what I want you to do is I want you to email this to me. So we know that Z can be expressed as P minus, or P hat minus P times P times, and we can put Q there, or we can put 1 minus P. So I want you to email to me what Z is when P hat is 32 out of 50, P is 0.60, and N is 412. Round to 2 places. So send this to me in an email by the time lesson number 5 is due, or assignment number 5 is due in my stat lab, and you'll get 25 out of 25 points. All right, gang, hang in there. We're almost through the course. Only 3 lessons, 5, 6, and 7. Yeah, 3 lessons remain. And I will tell you, I think that this lesson number 5, I think is one of the easiest ones. Lesson number 6 gets a little challenging. I think it's one of the more challenging ones, aside from lesson number 2. And then lesson number 7, I think, is a lot, some easy stuff too. All right. All right. Perfect timing. All right, gang. Hang in there. Take care.